Hey guys, in this video we're going to learn about a simple electrical circuit and some of the fundamentals of electricity. So let's start by drawing a simple electrical circuit which has a positive and a negative node of a battery, and it also has a switch which helps us to turn the circuit on or off, and it typically has a resistor, which in this case is an electrical bulb which will glow. So as soon as we turn the switch on, the circuit closes, electricity flows through the circuit, and the bulb turns on or glows. Now we can switch it off, and there you go. Now, some of the basic questions that we will answer in this video are: how does electricity work? At the fundamental level, what is it that causes this electricity or flowing of electricity? What does it even mean by that? And to understand that, we have to go at a subatomic level. So let's go down deep and look at an individual atom. As you probably know, an atom is made up of a central part, which is called the nucleus. It contains positively charged protons and the neutrons, which are neutral in charge. Now, around the nucleus, there is also electrons, which are negatively charged, and they are orbiting around the nucleus. Now, in a typical atom, the number of protons and the number of electrons are equal. So there is an equal number of positive and negative charges, and they kind of cancel each other out. So the net charge is zero. Now, we also know that metals are considered as good conductors of electricity. Why is that? So here's another model of how the atom looks. You have the nucleus in the center, and you have electrons orbiting in different orbits. Now, the electron in the farthest orbit has the weakest force of attraction, keeping it in orbit around the nucleus. And this electron can easily be knocked out of orbit and made available to conduct electricity. And these electrons are called as valence electrons or even free electrons in a metal. And these free electrons can actually help conduct electricity. So let's consider a wire that's made up of a metal such as copper or aluminum. And if we take a cross section of this wire, you see the blue atoms and you see these tiny dots that are pointing in different directions are the free electrons. Now, these free electrons are moving around at random. What this means is they're not moving in any particular direction, and as a total, their motion cancels each other's motion out, and there is no net charge. So there is no net charge, same number of protons, same number of total electrons, so the net charge is still zero. Now, if we apply a voltage across the two ends of this wire, which means we connect it to a battery, then something interesting will happen to these randomly moving free electrons. As soon as a battery is connected, let's say we connect the positive end of the battery to the right end of this wire and a negative node of the battery to the left end of this wire, all of these electrons, they will align in a particular direction. Now, if you notice, negative charge of the electron and the negative node, they repel each other. So the electrons are trying to run away from this negative node, and they are attracted to the positive end or the positive node of the battery, and they're trying to move in that direction. And that's exactly what happens as soon as we connect a battery. All of these free electrons are now moving at a constant speed or in a uniform direction or in a uniform motion from left to right, from the negative end of the battery to the positive end of the battery. And this is what is called as current. So as soon as we applied a voltage, the current started flowing. Now, what if we applied an additional battery, which means instead of just one batteries, if we put one more battery, so now there are two batteries, so we connect two batteries in series to each other. So we kind of doubled the voltage, and as you can see, looks like the electrons are moving faster. So obviously, instead of just one battery, now we have two batteries that are trying to push these electrons from the negative side to the positive side. And so there's twice as much force that they can apply, and so these electrons seem to be moving really fast. Well, wait, what about if we added a third battery? You think that might make any effect? Let's try it out. So if we add a third battery again we add the three batteries in series and then see what's going to happen to the electrons. Wow, now the electrons are flowing even faster. There is a huge current of electrons flowing through the wire. And as we kept on adding these batteries, which is we kept on increasing the voltage, we got more and more current. All right, so now I think we might be ready to go back to our electrical circuit and define some of the key terms. So the first term we want to define is voltage. The battery provides the voltage, which is also known as potential difference or the electromotive force. It's the force or it's the energy that it takes to push the charges or push those electrons, right? Remember we saw from the negative side to the positive, right? The other definition we want to look at is current. Current helps us measure how much charge is flowing through a conductor in 1 second. It's nothing but the flow of charges per second. So the more electrons are flowing through a wire in 1 second, the higher the current. So remember, voltage is the energy that the battery provides to push the charges, and current is the measure of how many charges are flowing through the circuit. And we saw for one set of voltage, we had one set of current. As the voltage changes, the current also changes. Right. I have a question for you now, and let's see if you can get it right. Is there a relationship between current and voltage? And if so, what is that relationship? You have 5 options, and I would love for you to answer this question in the comments section below. So read all of the 5 options. You can pause the video now over here and think of what your answer is going to be and enter the answer in the comments section below. And if you like this video, hit the like button so it'll motivate me to make more videos like this. Thank you.